All right, Professor Cooper, right back. Just finished the video on data frames, and now we're moving on to lists. Um, Lists are one of the most complicated, flexible, useful forms of objects in R. A list can contain pretty much anything in it. It can take objects of any dimensions within them in a sequence. Okay, lists can have numbers, characters, vectors, data frames, matrices, spatial data sets, other lists, and other stuff, arrays, anything. Okay, so the only way I think I can introduce you to a list and have you understand it is to motivate it with an example. And the way I'm going to motivate it with an example is to go through all the objects that we have created in all the videos so far, and we're just going to stuff them together into a list. Okay. So I'm going to go back through this script that we've been building, and you see we've got apple, banana. Those are individual numbers. A is a vector. Mix is a vector. Mix2 is another vector. Colors is a vector. Colors factor is a factor variable. Agree is a vector. Agree factor is a variable. Is a factor. I'm sorry. Um, let's see. Matrix 1 and 2 are just matrices. Data 1 is a data set. Okay, so we've got all those different things. They're all different types of objects. They have different dimensions. Like apple and banana are just single numbers. Mix was a vector of numbers. Colors was a character string vector. Agree factor is a factor variable. Matrix 2 is a matrix. And data 1 is a data frame, right? But those will all equally go into lists in sequence and not be a problem. Okay, I just created a list using the list function, and literally just, if I've already created these objects, then they can all go right into this list. And now I'm going to show you the list so you can see it. Now let's look for a second at the structure of the list. So see, we have some individual numbers. We've got a vector. We've got another vector. We've got the character string. This one is the factor because you can see the levels, right? This one is a matrix. You can tell because of the labels here that indicate column, and the labels over here that indicate row. Down here it's a data frame because it has labels and it has an observation counter. You see the subtle distinction between how you can see. I don't even need to like write class object. I can just tell that this is a matrix and this is a data frame, for example, right? But with respect to the list, look at the weird double bracketing, all right? This is how lists operate, okay? I'm going to explain the double bracketing here. Key to the list is this double bracketing thing. So you use one set of brackets to point to one of the sub elements in a list, but not to go inside and get its values or do something with them, okay? So I can say go right here. I do list underscore 1 hard brackets 3, just doing one of them. This points to that numeric vector that was the third element, right? That was a mix, I think it was. And yeah, no, it was A. It was this A vector, right? Okay. I can't subset on this and do anything with it. If I try, let's say I wanted to get to, from the list itself, go into the A vector, get the third, no, let's say the fourth value, and do something to it. Normally in a vector, I would put a hard bracket after and just pick out the number, but look what happens. Nothing. It's searching for something and not finding anything. Okay? Well, that's not helpful. It's not actually inside the vector at this point. It's literally pointing you to the vector. Instead, let's do double brackets and see what happens. All right. Okay, looks very similar. But if I do something like put a single bracket and put the 4 after and I hit enter, it now says, oh, look, I'm inside the vector. I can go into the sequence, find the 4th thing in the length of the vector, and show it to you. It is a subtle distinction. It's very important for you to understand lists this way. Okay. The second bracket allowed you to not just point to the vector, but to get inside it and get to the values inside it and do something with them. Okay. So in theory, I could also recode. If I wanted to list so I'm going to that same piece, the one that is inside A, that is inside the list, and I'm recoding it to 999. I should be able to. Oh, because I see real coding errors on the fly. I'm just going to leave that in the video. I didn't put the 1 there. All right. Now, if we reprint, you can go back up here and you can see that inside the list, it changed it to 999. It would not have worked with a single bracket on the 3 because it was only getting me to that point. It wasn't getting inside to the values. The last thing I want to show you about lists is that lists can actually take lists inside them. All right. Let's see. I'm going to create a second list. That's just Apple and matrix 1 and agree. So a couple of things that weren't in the original matrix, right? Now I'm going to make a third. And that third is going to be I'm actually going to, no, I'm going to rewrite. Yeah, we'll make it a third. Yeah, we'll make it a third. List 1, and list 2. So now this is getting pretty meta in the sense that we've got list on list on lists. So we are, in a sense, double listing. We have all that information inside it. You can see how this can easily get very complicated and a lot of information can be stuffed inside a list. When we get to mapping and things like mapping COVID data, doing some dynamic plots with mapping, things like that, and we need some spatial data points, you're going to find data structures that are very similar to this crazy turducken listing within listing within listing kind of scenario. But we'll be able to navigate it because you'll have had some practice with lists, hopefully. All right. Be safe. See you later.